Welcome to Tungal Online Classes. Today we are going to discuss the new concept is vehicle coming to rest on a horizontal surface. Okay, here we are consider a vehicle of mass m. It is moving with the initial velocity that is v. Okay, see here, this is the road and let us assume that this is a vehicle. The mass of this vehicle is somewhat m. Here m indicates that the mass of the vehicle and v indicates that the initial velocity of that vehicle, and mu indicates that it is the coefficient of a friction between the tire and the surface of the road. So, here mu indicates that it is the coefficient of a friction between the tire and the surface of the road. Okay, see here, in this case the driver inside the car, he applies the brake means, so that vehicle comes to rest after traveling some distance. Okay, see here, if the driver apply a brake to this system or this car, so that car will come to rest after traveling some distance. Okay, in this case we are going to find out what is the stopping distance of this car or the stopping distance of the vehicle. Okay, see here, according to work energy theorem, so that the work is equal to change in kinetic energy. The work done by the force, that is equal to change in kinetic energy. So, this is a statement of a work energy theorem. So, we will discuss this theorem in the next chapter. So, here just remember the statement of this theorem. So, that is work done by the force, that is equal to change in kinetic energy. So, already we know that the work done means it is a product of force and displacement. Here the work done means it is a product of force into displacement into cos theta, right. So, this is a dot product of force and displacement. The work done formula is, that is Fs cos theta. F indicates that the force, S indicates the displacement, cos theta. Here theta indicates that the angle between the force and the displacement, the angle between force and the displacement. So, then change in kinetic energy. So, that is final kinetic energy minus initial kinetic energy. Final kinetic energy minus initial kinetic energy. Okay, see here. So, in this case the vehicle is moving in this direction, but the frictional force is acting in opposite direction. The friction force is acting in opposite direction, and the displacement of this particle or this body, that is in this direction. See here, the friction force acting on this vehicle in this direction and the displacement of this vehicle in this direction, then the angle between these two is, that is 180 degree. The angle between these two is 180 degree. Okay, substitute here, the force is, that is friction force, it is denoted by small f, into displacement is S, here cos theta. So, theta value is, that is 180 degree, that is equal to final kinetic energy minus initial kinetic energy, that is 1 by 2 m into v square minus 1 by 2 into m into u square. So, here cos of 180 value is, that is minus 1. So, that it becomes f into s minus f into s, that is equal to 1 by 2 m into v square minus 1 by 2 m into u square. So, in this case the finally that body comes to rest means final velocity of that body is 0. The initial velocity of that body is v and the final velocity of that body is 0. Substitute here, this is equal to 1 by 2 m into final velocity is 0 minus. So, this is 1 by 2 as it is, mass as it is, and initial velocity of this body, so that is v square, that is v square. Okay, the next one, see here, this is minus F into S, friction force into displacement, that is equal to minus of 1 by 2 m into v square, minus of 1 by 2 m into v square. In this case minus sign both are get cancelled. Then here F indicates that the friction force and S indicates that the stopping distance. So, this is the S, this indicates that stopping distance. So, here we want the S value. So, that is stopping distance is equal to 1 by 2 m into v square divided by friction force. So, already we know that the friction force, that is equal to mu into n. Here what do you mean by n? That is a normal reaction. So, the weight of this vehicle is balanced by the normal reaction. So, then n is equal to m into g. So, here n value is, that is m into g. Substitute here, then friction force, that F is equal to mu into m into g. Okay, then substitute this F value in this equation. The stopping distance, that is equal to 1 by 2 m into v square divided by mu into m into g. So here m get cancelled, then the stopping distance is equal to 1 by 2 v square divided by mu into g. So this gives the stopping distance of the vehicle. So that means the vehicle comes to rest after traveling this much of distance, right? So this is known as the stopping distance. So there are two methods to find out the stopping distance. So this is a one method with the help of a work energy theorem. Okay, see here in this case, initially we are consider a vehicle of mass m, it is moving with the initial velocity, that is v. So here mu indicates that is the coefficient of a friction between the tire and the surface of the road. So if the driver inside the car, he applies the brake, means so that car travels some distance before coming to rest. So it before coming to rest means, so in this case the finally that body comes to rest, so final velocity of that body is 0. So then according to work energy theorem, so work done by the force, that is equal to change in kinetic energy. So work done is nothing but it is a product of force into displacement into cos theta. Here F indicates that the force, S indicates the displacement, theta indicates that angle between the force and displacement. So that is equal to final kinetic energy minus initial kinetic energy. Okay, see here the force acting on this vehicle is, that is a friction force, it is acting in this direction, and the displacement of the vehicle in this direction. Angle between these two is 180 degree. So substitute here, theta is 180, cos of 180 is equal to minus 1. So then this becomes minus F into S, that is equal to change final kinetic energy minus initial kinetic energy. Final velocity of the body is 0. So then final kinetic energy is 0 minus initial kinetic energy, that is 1 by 2 m into v square. Here minus and both are get cancelled. Then S is equal to stopping distance is equal to 1 by 2 m into v square divided by F. F indicates that friction force. So then the friction force value is F is equal to mu into m into g. So substitute the F value in this equation, then the stopping distance is equal to 1 by 2 v square divided by mu into g. So this is stopping distance, right? Okay, see here the one more method to calculate the stopping distance. So that is, so in this case the vehicle, it is initially moving with some velocity, that is v. So after the driver applies the brake, means it comes to rest. So at that case the net force acting on the system, that is equal to friction force, right? So here the force acting on this vehicle in this direction and the friction force is acting in opposite direction. So net force is nothing but mass into acceleration and the friction force. So that friction force, that is F, means it is a mu into m into g. So in this case m both are get cancelled, then A is equal to mu into g. So in this case the force acting on this vehicle is, that is retarding force. So retarding force means, so that is in opposite direction. So then acceleration becomes, that is minus. So here acceleration of that body A is equal to minus mu into g. So in this case why we are consider here this minus sign, because the retarding force is acting on this body, that's why we are consider this is a minus sign. So retarding force, here F suffix R indicates that retarding force, that is equal to friction force. So retarding force means that is minus m into A, that is equal to mu into m into g. Here m get cancelled, then acceleration of that body is equal to minus mu into g, Okay, next here we are going to find out the stopping distance. We are using the equation of motion, that is v square minus u square, that is equal to 2as, Here the final velocity of this body is 0, that is equal to minus initial velocity of this body is v. So that is v square, that is equal to 2, and here acceleration is minus. So this is minus mu into g into s, right? Okay, from this relation, this minus sign both are get cancelled. Here we want the s value. So s is equal to, stopping distance is equal to v square divided by 2 into mu into g, v square divided by 2 into mu into g. So this is also stopping distance. So there are two methods to calculate the stopping distance. The first one is with the help of a work energy theorem, and the second one is with the help of a retarding force. So here the retarding force, that is equal to friction force. So retarding force means that is minus m into a, that is equal to mu into m into g. Mass get cancelled. Then the acceleration of the vehicle, that is equal to minus mu into g, minus mu into g. So here we want to calculate the stopping distance. For that one we are using the equation of motion, that is v square minus u square equal to 2as. So here the final velocity of the vehicle is 0 minus initial velocity is v square, that is equal to 2 as it is, and the acceleration value is mu into g into s. S is nothing but stopping distance. So then s is equal to v square by 2 into mu into g. So this is about the stopping distance. So next one we are going to find out the stopping time. Okay, see here, with the help of the equation of motion, that is v is equal to u plus at. V is equal to u plus at. Here the final velocity is 0. This is equal to initial velocity u, and acceleration is minus a into t. So from this one, minus u is equal to minus a into t. Minus and both are get cancelled. Here initial velocity of the vehicle is, that is v. V is equal to acceleration a into t. So then t is equal to v by a. So then what is the acceleration of the system here? The acceleration of the system is, that is mu into g. Acceleration of the system is, that is mu into g. Then t is equal to v divided by mu into g. So this is the stopping time. So the minimum time to take the vehicle comes to rest. So that is known as the stopping time. So here we are using the equation of motion, that is v is equal to u plus at. So here the final velocity is 0 and initial velocity is u, and acceleration, that is minus, right? So minus a is equal to mu into g into time. So here the minus a value is, that is mu into g. So then t is equal to v divided by mu g. So this gives the stopping time. So stopping time means the minimum time taken by the vehicle to come to rest. The next topic is pseudo force, right? So before this one we will discuss what do you mean by frame of reference and what are the types of frame of reference. The first one, frame of reference means any coordinates relative to which we describe position or motion of the object or the body is called frame of reference. So what is the definition of a frame of reference here? Any coordinates relative to which the position or the motion of the body is described, so that is known as the frame of reference. In a frame of reference there are two types. The first one is inertial frame of reference and the second one is non-inertial frame of reference. So in inertial frame of reference, so the frame of reference which obey Newton's laws of motion, so that is known as the inertial frame of reference. So here what do you mean by the inertial frame of reference? A frame of reference which obey Newton's laws of motion, so that is known as a inertial frame of reference. And the non-inertial frame of reference. So non-inertial frame of reference means a frame of reference which does not obey Newton's laws of motion, so that is known as the non-inertial frame of reference. Okay, in order to apply the Newton's laws of motion to the non-inertial frame of reference, we introduce the new concept is, so that is pseudo force, right? So here we are going to apply Newton's second law to the non-inertial frame of reference. For that one we are introduced the new concept is pseudo force. Here the pseudo force, it is always acting opposite to the direction of a motion of the body. For example, see here, consider a vehicle. So consider this is a vehicle. It is moving in this direction, or the acceleration of this vehicle, it is in this direction. In that case, the pseudo force acting on this body in exactly opposite direction. Exactly opposite direction. Okay, see here, in this case the pseudo force, it is always acts exactly opposite to the direction of accelerating of the body. Direction of the accelerating of the body. Here the next topic, body placed on an accelerating track. Body placed on an accelerating track. Okay, see here, consider this is a track. So here let us assume that this is a truck, a block of mass m, it is placed on the open ended of the truck, right? Here the mass of this block is m, and at a distance x from the open end. Okay, see here, let m be the mass of this block and at a distance x from the open end of the truck. Okay, in this case, this truck, it starts from rest and accelerating in this direction. In this case, A suffix t, it indicates that the acceleration of the truck in this direction. So now this becomes a non-inertial frame of reference, because so this truck is accelerating means, so this becomes a non-inertial frame of reference. In a non-inertial frame of reference, if you want to apply the Newton's second law, we introduce the concept of pseudo force. So here the pseudo force acting on this block exactly opposite to the direction of accelerating of the truck. Okay, see here, in this case, this truck is accelerating in this direction and the pseudo force acting on this block in this direction. So the direction of a pseudo force, it is always opposite to the direction of accelerating of the truck. Here A suffix t indicates that is acceleration of a truck. Here F suffix p, it indicates that pseudo force. If F suffix p indicates that pseudo force. Okay, see here. After that, so in this case, the weight of the vehicle, it is acting in the downward direction, right? And the normal reaction, it is acting in upward direction. So here, this is the direction of a pseudo force. So this is the direction of a pseudo force, and the friction force, it is acting in this direction. The friction force, it is acting in this direction. Okay, see here. Then the normal reaction value here, the normal reaction, that is equal to weight. Weight is nothing but mass into acceleration due to gravity. Okay, then the friction force experienced by the block, so that is the friction force, that is F is equal to, in this case the block is at rest means the static friction comes into play between the block and the surface of the truck. So here the friction force, that is equal to mu suffix s into n. So this is equal to mu suffix s m into g. So this is a friction force acting on the block. So this is a friction force acting on the block. Okay, see here, if the system is under equilibrium, so then the pseudo force, it is less than or equal to the friction force. So in this case, this body is under equilibrium. In that case, the pseudo force, that is less than or equal to the friction force. Okay, see here, the pseudo force, that is F suffix p, that is less than or equal to friction force, that is less than or equal to friction force. Here the pseudo force is nothing but, that is mass into acceleration, Okay, see here, that is mass into acceleration of the truck. So the magnitude of the pseudo force is less than or equal to the friction. Here the magnitude of a pseudo force value is, that is m into acceleration of a truck, that is less than or equal to friction value, that is mu into m into g. So in this case, m both are get cancelled. Then A suffix t, that is less than or equal to mu into g, that is mu suffix s into g. So this is the maximum acceleration of the truck. This is the maximum acceleration of a truck which can move without sliding the block, Okay, see here, the next one, if the pseudo force, it is less than, if the pseudo force is less than limiting friction, Okay, see here, if pseudo force is less than limiting friction means the body does not changes its position. The body or block does not changes its position, so that means it is rest. Okay, so in this case, the pseudo force, that is equal to friction force, that is the limiting friction. Pseudo force, that is equal to limiting friction. So then the friction is equal to mass into acceleration of the truck, that is force is equal to mass into acceleration of the truck. Okay. In the next case, if pseudo force it is greater than friction force, pseudo force it is greater than friction force. Okay, see here, if the pseudo force is greater than the friction force, means in that case this block starts sliding in this direction, because the pseudo force is more comparing to the friction force. If pseudo force is greater than the friction force, means this block starts sliding in this direction. So then the net force acting on the system, or the net force acting on the block B, net force acting on the block B. See here, net force acting on the block B. Okay, see here. So this is the block B. Here the net force acting on this block B is, that is pseudo force minus friction force. So the net force, that is F suffix n, that is equal to pseudo force minus friction force, right? So here this body or this block starts sliding on the surface of the truck, means, so this is the kinetic friction, the friction between the block and the surface of the truck. So that is the kinetic friction. Okay, see here, the net force acting on the block, so that is equal to mass into acceleration of the block. Here A suffix B indicates that is the acceleration of the block, and here the pseudo force is nothing but that is mass into acceleration of the truck minus, here kinetic friction is nothing but that is mu suffix k m into g, mu suffix k, that is m into g. Okay, see here, take m common here, then m A suffix B, that is equal to, take m common, A suffix t minus mu suffix k into g. So in this case mass get cancelled, then acceleration of a block, that is equal to acceleration of a truck minus coefficient of a kinetic friction into acceleration due to gravity, So this is the acceleration of the block. Okay, see here, the first one we are considering, this is a truck, a block of mass is placed at the rear side of the truck at a distance x from the open end, and here m indicates that the mass of this block. So here this truck, it starts from rest and accelerating in this direction. Here A suffix indicates that acceleration of the truck. So this is accelerating system, is this becomes a non-inertial frame of reference. In non-inertial frame of reference, we are not able to apply the Newton's second law. To apply the Newton's second law, we are introduced the concept of pseudo force, and the direction of pseudo force, it is always opposite to the direction of a accelerating truck. So here the truck is accelerating in this direction, and this is the direction of a pseudo force. So after that, the weight of the block is acting downward direction, and the normal reaction is acting in upward direction, and this is a friction force, and this is the direction of a pseudo force. The first one, the normal reaction on this block, that is n is equal to m into g, then the friction force is mu suffix s into m into g. Mu suffix s indicates that it is a coefficient of a static friction. Okay, the first one, if this system is under equilibrium, the pseudo force is less than or equal to the friction force. So then pseudo force is, that is m into A suffix t less than or equal to mu suffix s m into g. Here m get cancelled, then the acceleration of the truck, that is less than or equal to mu suffix s into g. So this gives the maximum acceleration of a truck which can move without sliding the block, right? Okay. In next condition, if the pseudo force is less than limiting friction, if the pseudo force is less than limiting friction, in that case that body does not changes its position. So that means pseudo force is equal to limiting friction. That means pseudo force, that is equal to limiting friction. So then limiting friction or friction is equal to m into A suffix t. Here m indicates that mass and A suffix t indicates that is acceleration of a truck. And the next condition, if the pseudo force is greater than friction. If the pseudo force is greater than friction, in that case this block starts sliding in this direction, right? So here the net force acting on this block, that is equal to pseudo force minus that is a friction force. Here the net force is nothing but mass into acceleration of the block, that is equal to pseudo force is mass into acceleration of a truck minus mu suffix k into m into g. Here take m common, so then the acceleration of the block, that is equal to a suffix t minus mu suffix k into g. Here acceleration of a block, that is equal to acceleration of a truck minus coefficient of a kinetic friction between the block and the surface of the truck into acceleration due to gravity, Okay, so here next we are going to find out what is the time taken by the block to cover this x distance, right? Okay, so here with the help of the equation of motion, so that is s is equal to ut plus half at square. S is equal to ut plus half at square. So in this case, initially this block is at rest. Means initial velocity of the block is 0 and the distance covered by this block is, that is x, right? So here the s is nothing but, that is x. The distance covered by the block is x, that is equal to initial velocity is 0 into t plus 1 by 2, and this acceleration of a block as it is, this acceleration of a block into t square, right? So 0 into any term is 0. So in this case we want the t value. So see here the t is equal to, I will write the equation here, that is t is equal to under root of, that is 2x divided by acceleration of the block B. Okay, so here we are using the equation of motion is, that is s equal to ut plus half at square. Here the distance covered by the block, that is x, and initially that block is at rest, means initial velocity of that block is 0. So then x is equal to, that is x is equal to 1 by 2 acceleration of the block into t square. Here we want to calculate the t value, that is t is equal to under root of 2x divided by acceleration of the block. So then t is equal to under root of 2x as it is, and the acceleration of the block B is, that is acceleration of a truck minus coefficient of a kinetic friction into acceleration due to gravity. Okay, here this is the time taken by the block to cover this much of distance. The next one we are going to calculate then what is the velocity of the block at instant it leaves the truck. Okay, so here we are using the equation of motion, that is v square minus u square is equal to 2as. So here the initially that block is at rest, means initial velocity is 0, then this is acceleration of a block and this is a distance. Okay, see here then velocity, that is v is equal to under root of 2 into acceleration of a block is acceleration of a truck minus mu suffix k into acceleration due to gravity into x. Sorry, here into s. S is nothing but, that is distance. So that is ex. So this formula we are used to find out the velocity of the block at an instant it leaves the truck. So that is v is equal to under root of 2 bracket of a suffix t minus mu suffix k into g bracket of x. The next one, a body placed in contact with the front surface of an accelerating truck. Okay, here consider, or let us assume that this is a truck. In this case we are placed a block of mass m in contact with the front face of the truck. See here the m indicates that is the mass of the block. Here m indicates the mass of the block. So in this case this truck is accelerating in this direction. This truck is accelerating in this direction. So here if the truck is accelerating in this direction, the pseudo force acting on this block in this direction. Here f suffix p indicates that the pseudo force acting on this block in this direction, and the normal reaction it is acting in this direction. The normal reaction acting in this direction, and the weight of this block it is acting in this direction, and this is a friction force. So that is friction force is acting in this direction. So this is F suffix S. That is the static friction between the front face of the truck and the block. So in this case, this system is under equilibrium. So then the normal force acting on this system, that is equal to pseudo force, that is F suffix P. So after that, the weight of the block, it is balanced by the friction force. Weight of the block is balanced by the friction force. Okay, see here. So from this one, that is N is equal to F into P. So then weight is nothing but it is the product of mass into acceleration due to gravity, that is equal to, here F suffix S means that is static friction, that is mu into N. So that is mu into N. Here what is the normal reaction value? So that is F suffix P, right? Okay, see here, that is M into G, that is equal to mu. Here N value is, that is the pseudo force. The N value is, that is pseudo force, that is F suffix P. So from this one, pseudo force, that is equal to mg divided by mu. So this is one expression, and another expression, that is mu suffix S is equal to mg divided by here force is nothing but that is mass into acceleration. Here mass get cancelled, then coefficient of a static friction, that is equal to G divided by A, or A is equal to G divided by coefficient of a static friction. Okay, see here, in this case we are placed the block of mass, it is attached to the front face of the truck, and this truck is accelerating in this direction. If the truck is accelerating in this direction, means the pseudo force acting on this block in this direction, and this is the direction of a normal reaction. After that, the weight of this block is acting in downward direction, and the frictional force is acting in upward direction. Okay, see here, then the normal reaction value is, that is the pseudo force, right? So after that, here friction force is balanced by the weight of the block. So that is weight is equal to friction force. The friction force is nothing but it is a product of mu into N. Here normal reaction value is, that is F into P, that is M into J is equal to mu into F suffix P. So from this one, F suffix P is equal to mg divided by mu suffix S, or mu suffix S is equal to G divided by A, or A is equal to G divided by mu suffix S. So here this the minimum acceleration of the truck for which the block will be under equilibrium. So this gives the minimum acceleration of the truck for which the block will be under equilibrium. Consider a block of mass M. So this is a vertical wall. So here we are placed a block of mass M. It is in contact with vertical wall. So here M indicates the mass of the block, and mu indicates that it is a coefficient of a friction between the block and the surface of the wall. So here we are applying some horizontal force in this direction. To keep the body under equilibrium. So in this case, the weight of the block is acting in the downward direction, and the friction force is acting in upward direction, and here we are applying some external force on this block in this direction to keep the body under equilibrium. At the same time, the normal reaction, it is acting in this direction. So here the system is under equilibrium. So then this force is balanced by this force, and this force is balanced by this force. So here the external force that is equal to normal reaction. And here the weight is equal to friction force. That is weight is equal to friction force means that is mu into N. So then weight is nothing but mass into acceleration due to gravity. So that is mu. N value is, that is F. So from this one, F is equal to M into G divided by mu. So this is a minimum force we require to keep the body under equilibrium. So initially we are consider a block of mass M. It is placed in contact with a vertical wall. So here we are applying some external force F in this direction to keep the body under equilibrium. So here the external force F is acting on the body in this direction, at the same time the normal reaction acting in this direction. So then the weight is acting in downward direction, the friction force is acting in upward direction. If the system is under equilibrium, the horizontal force is balanced by the normal reaction, that is F is equal to N. So after that, weight is balanced by the friction force, that is W is equal to F. Then so friction force is nothing but it is the product of mu into N. N is nothing but that is F. Then mg is equal to mu into F. So then F is equal to mg divided by mu. So this is the minimum force required to keep the body under equilibrium. Keep the body under equilibrium. Thank you.